Hello students, this is Sandeep sir here. In this video, I am going to explain one of the very important topics of electricity, that is resistors in parallel. Okay, so please watch the video till the end. I'm going to do the derivations and one simple problems based on resistors in parallel. Okay, but when we can say that resistors are connected in parallel, first you understand these concepts. Okay, I'm just taking, there are three resistors. Let's take, this is R1, another resistors R2, another resistor R3. Okay, let's take one end of this is connected to one common end and other end is connected to the other common end. Such connections are called as parallel connection, end to end connection, children. Okay, see, one end of each resistor is connected to one common end. Let's say this is A and other end is connected to the other common end, that is, let's say this B. Now, if this combination is connected to the battery of V volt, okay, so we have to derive here 1 by R equivalent, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this derivation they may ask for 3 marks, children. Okay, now see, we'll start. Okay, yeah, it's the battery, let's say battery is of V volt, I current passes through the battery. Okay, it shows I current. Now see here, children, at this point A, there are three different paths are there, right? So and this is different values of resistors are there. So current will divide, children, here at A. Let's say current at passing through R1 is I1, through R2, let's say current is I2, through R3, current is I3. So from this circuit, what happens? The current divides, we can say I is equal to I1 plus I2 plus I3. This is also according to the Kirchhoff's current law. You should know KCL. Okay, it is there in the second PUC or 12th standard. You will learn to. Okay, KCL is what? Kirchhoff's current law. Kirchhoff's current law states that at the junction, entering current is equal to leaving current. So this A is a junction, children. What is entering current? I. Okay, now what are the leaving currents? I1, I2, I3. So we can write I is equal to I1 plus I2 plus I3. Let's say question 1, children. Is it clear? Now, what is common in this? You see, one end of R1 is A, other end is B. Similarly, one end of R2 is A, other end is B. Similarly, one end of R3 is A, other end is B. So, potential difference is same. Okay. Similarly, you see this battery. One end of this is A, other end is what? B. So, here potential difference is same, children. V1 is equal to V2 is equal to V3 is equal to V. That you have to keep it in mind. In parallel, potential difference is same, current divides. Okay. Now I want the value of I1, I2, I3. Okay, let's see. We can write a current through R1. What is the current through R1, children? I1. I1 is equal to what? V1 by R1 from Ohm's law. What is V1? V1 is nothing but V. We can write V by R1. Similarly, current through R2. What is the current through R2? I2. I2 is nothing but V by R2, because V2 by R2 we can write V2 is nothing but again V. Similarly, we can write current through R3. This current through R3, this is I3. I3 is again what? V3 by R3. V3 is nothing but V. So V by R3. Okay. Let's take this equation A, B, C. Okay. Now what I am doing? I am removing these three resistors. I am putting one equivalent resistor whose value is Rp connected to the V volt battery. Now what is going to same? Current is going to same, right? Same current will pass through this, right? I current will pass through this Rp, right? So we can write once again current through Rp. What is current? I. I is nothing but potential difference by V by Rp. V by Rp. Let's see question D. Okay, using A, B, C, D in equation 1, children. Okay, what I am doing? Using equation A, B, C, and D in equation 1. In equation 1. What is equation 1? This one. Okay, I is equal to what? I1 plus I2 plus I3. Okay, what is I? V by RP. Substitute the value, children. V by RP is equal to what is I1? V by R1. V by R1 plus I2 is what? V by R2 plus what is I3? V by R3. Is it clear? Now what we can write? We can take V common on the right hand side. V by RP is equal to, here if you take V common, so 1 by R1 plus 1 by R2 plus 1 by R3. Now we get cancelled, so finally we can write 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the derivation they are asking in the exam. Okay. Now try to understand, okay, if I am taking two resistors of equal values, let's take this is R and another resistor R is there connected in parallel. So what is that? What is the R equivalent of this? See, we can apply the formula 1 by RP is equal to what? 1 by R1, okay, plus 1 by R2. So R1 is R only, R2 is also R only, right? So 1 by RP we can write, okay, this is 2 by R. So from here we can write RP is equal to R by 2. If two equal values resistors are connected in parallel, so RP is equal to R by 2. Just remember this one. Okay, one more short tricks you can create or you can make just take there is a resistors R1 is there, another resistor R2 is there connected in parallel. Okay, so apply the formula 1 by RP is equal to what? 1 by R1 plus 1 by R2. So 1 by RP you can write R1, R2 is the LCM. Okay, R1 into R2 is the LCM. This denominator divided by R1, you get R1 cancel, you get R2 into 1. Okay. Similarly, R1, R2 divided by R2. R2, R2 get cancelled, you get R1 into 1. Okay, so we are getting what? 1 by RP is equal to R1 plus R2 by R1 into R2. So what will be the RP, children? RP is equal to R1 into R2 divided by R1 plus R2. Directly we can use this formula if two resistors are given. Okay, I'm taking one example. Okay, let's take there is a resistor. Okay, 20 ohm, another 30. Okay, let's take 30 ohm is there connected in parallel. So if you want to solve, you can apply the formula. Okay, directly you can solve. RP is equal to what? R1 R2 divided by R1 plus R2. This formula I'm talking about. Okay, so you can write 20 into 30 divided by 20 plus 30. So you can write 20 into 30 divided by 20 plus 30, how much? 50. This will get cancelled. 5 1 ja 5 6, right? It is 12 ohm. Remember one thing, children, RP value, okay, whatever we are getting is always less than the resistors which are connected in parallel. Less than resistors connected in parallel. Connected in parallel. Is it clear? Getting so you see this we are getting RP 12 ohm. Is it less than 20? Yes. Okay, is it less than 30? Yes. So RP is always less than the resistors connected in parallel. Okay. Okay, let's take one simple question, children. I have taken totally there are three resistors. Let's take this is 10 ohm, 20 ohm, okay, and 30 ohm. Okay, they are connected in parallel circuit and all are connected to a 100-volt battery. Okay, my question is find the R equivalent of the circuit and what is the current I flowing through the circuit. Okay, so we can apply the formula 1 by RP is equal to what? As you know, resistors in parallel formula 1 by R1 plus 1 by R2 plus 1 by R3. Yes or no? That is equal to 1 by RP. So 1 by RP we can write is equal to 1 by R1. What is R1? You can assume this is the R1, R2, and this is R3, right? So 1 by 10 plus 1 by 20 plus 1 by 30. Okay. Next, you can write 1 by RP is equal to, take the LCM of 10, 20, and 30. LCM will be 60. Okay, 60 divided by 10, you will get 6 into 1 plus 60 divided by 20, you will get 3 into 1. Next, 60 divided by 30, you will get 2 into 1. We are getting, children, 1 by RP is equal to 6 plus 3, 9 plus 2, 11 by 60 ohm. So this is 1 by RP. Most of the students will write this only answer. Actually, this is 1 by RP, children. So RP, to get the RP, you have to take the reciprocal. So 60 by 11 ohm. Okay, this is the RP. Now to get the current, okay, we can find V by RP formula. V is how much? 100 divided by RP is how much? 60 by 11. Is it clear? So 11 will go to the numerator. So we can write 10 into, 100 into 11 by 60. 0 get cancel. We are getting the 110 by 6. Then you can cancel 55 times 3 times. So 55 by 3 ampere. 55 by 3 ampere. You can divide and write the decimal points also. I hope you understood these concepts of resistors in parallel. Okay, if you have understood, please share with your friends and subscribe the channel. Thank you, children.